Hi, and thank you for joining our webinar today. I'm Paul Hudak. I'm a business analytics consultant with LPA Software Solutions. Today we're going to look at IBM SPSS Modeler with a focus on the public sector. So when I say public sector, I'm talking mainly about universities, government organizations, and things like that. During our webinar today, I'm going to run through some early slides and talk to you about predictive analytics and data mining. So just to give you a sense of, well, number one, what is predictive analytics, and the scope of what data mining, what they are. Then we're going to take a look at, well, I'm going to try to stimulate your thinking about how data mining would benefit your organization. So I have some use cases in the public sector that we can talk about and go through. During this section, I'm hoping you'll get some ideas and be able to see how, how data mining not just has impacted other areas in the public sector, but how you, as a person working in the public sector, can leverage this type of technology. Again, we're going to see some examples of how other organizations are benefiting from deploying predictive analytics, and then I have a couple demonstrations that we're going to take a look at. Both demonstrations are taken from the education area of the public sector, but I do think they can be. I think they can be. Both of them could be adapted for different areas of the public sector. We'll get into that later. So, what is predictive analytics? Well, predictive analytics encompasses a variety of techniques, so statistics, data mining, game theory, among others. To analyze, we basically take all of these techniques and we use them to analyze large amounts of data, discovering new patterns and relationships. Typically, they're patterns and relationships that humans aren't able to see at face value. We leverage these techniques and tools to, make predictions. So the one key with predictive analytics is, yes, we can come up with a great model, but the deployment piece is always the piece where we take our prediction and make it actionable. So making predictive analytics actionable is a very key piece of what we're going to talk about today. So I can create all kinds of existing great models, but if I'm not able to take advantage of them in the real world, then it's no different than a research project. So we want to focus today on tangible things that we can take out of our predictive models. This is some examples of public sector use cases using predictive analytics, and we're looking at the first one here in the upper left, crime analysis. So how can we more optimally deploy our police force? So yes, we're talking about police force here, but I want to show you that deploying a police force isn't too much different than deploying a group of employees or workforce management. We're taking predictive workforce management and applying that in the crime sense here, at least in this statement, but workforce management can be applied across many different, not just public sector areas, but any kind of, really any sector, any type of industry, I should say. Which of our leads are the most promising? We can use predictive analytics to evaluate that. And you've also heard about hotspot detection, so trying to predict where crime is likely to occur in a city, a precinct, at that level. Those are all applications of predictive analytics in the crime portion of the public sector. Education, so this is a good one. The examples that I'm going to go through today are focused around education. So which students are at risk of failing? That's actually one of the demonstrations that we're going to cover today. I have some good reasons why we might want to know this, and some ways to identify return on investment with using that use case. So on the flip side of that, from all of our applicants, which applicants are the most promising? Well, we can use predictive analytics to determine which applicants have the most likelihood of succeeding at our university. And we can take predictive analytics and also look at the monetary side. If I'm a university, I'm dependent, or one of my revenue streams is the donation. How can I identify which alumni are likely to give me, which alumni are likely to donate? And from that group, to take that a step further, which groups of alumni are more profitable than others? And these are questions we're going to look at in our second example today. So This last area here, human capital management, this is something I put in here. This is really something. It could be. It's transcendent of any sector or industry. Which employees are most likely to leave? Everybody. If you're an organization and you have employees, who wouldn't want to answer that question? Well, we can take data and we can leverage the technology of a predictive analytics solution like SPSS Modeler and produce models that will give us an idea of which employees are most likely to leave. We can take it on the flip side also and look at potential applicants and try to draw out skills or potentially score potential applicants for their ability to do well in our organization. And kind of the end result of this is increasing and improving our employee retention. So there's a lot of different ways that we can get a return just by doing that. So we save money by retaining employees because we're not spending money to find new employees to replace them. And well, there's a lot of different ways that we're able to leverage that from an employee retention standpoint, leverage return on investment, I should say. So I just told you a little bit about predictive analytics and I gave you some examples. So hopefully I'm stimulating your thinking a little bit on how this can be used in your organization. I want to tell you a little bit now about SPSS and specifically IBM SPSS as a platform. Well, IBM SPSS Modeler is one piece of the SPSS platform. It comprises different areas of the predictive umbrella. So and you can see here from the icons that I have listed, we can use different aspects of SPSS to collect data, to analyze social media. We have a component here for statistics, so we can we can read in data and produce different statistics on the data. We also have the capability of I'll call it integration capabilities, and that can be the most difficult piece. Sometimes can be the most difficult piece when it comes to taking a predictive modeling solution and making it tangible or making it actionable. We have the ability with collaboration and deployment services to more easily integrate your models, your predictive models, into real-time systems or producing scored output to, say, like a data warehouse. You're not just tied to Modeler on your workstation or a piece of software on your workstation. You have a whole platform behind you, depending on what your needs are, to really take advantage and allow you to achieve the quickest ROI as possible. Today, I talked about I just talked about the IBM SPS platform. Today, we're going to focus on Modeler. IBM SPSS Modeler is what it's called. And Modeler, it's a great product. It's a very versatile data mining and analytical tool. Allows you to, as an analyst or as a data miner, or really just anybody that's interested in the tool, allows you to quickly connect data sources to the workbench, to the IBM SPSS Modeler workbench, and gain insights out of the data. IBM SPSS Modeler does this through it's a very visual interface, and you'll see when we get into the demonstrations, I'm able to drag and drop different nodes that do different things to achieve different results. I can analyze almost any kind of data with IBM SPSS Modeler. I can connect to my EDW, my Enterprise Data Warehouse. I can connect to something as simple as a flat file, so a CSV file. I'm not bound by structure of data either. So I can actually attach this to, for instance, I've listed social media here in this slide. I've also, me personally, I've used SPSS Modeler to mine comments from a verbatim survey. So we can take human language that's been typed into a survey and mine those for, well, for different reasons. We can determine sentiment. We can find themes that people are talking about. There's a lot of versatility behind this tool. We can also conduct analysis regardless of where the data is stored. So you're not tied to having the data on your specific workstation. If you have an enterprise data warehouse, you can take advantage of a connection directly to the warehouse if you desire. You can also connect SPSS Modeler to another tool under the IBM umbrella called Cognos. Typically, Cognos is used as an interface to a data warehouse for reporting. You can connect via Cognos. You can pull Cognos reports. Hadoop is another data source that you're able to connect to. Modeler is a great tool for somebody coming in that wants to learn about data mining, number one, but wants to be able to have a quick impact on the data that they're trying to analyze and uncover these unknown patterns. It allows for a very quick return on investment just because of the power behind this tool. I'm going to show you some quick ways today how we can really take the investment we've made in Modeler and turn that into some very tangible results very quickly. So we just talked about the IBM SPSS platform, and I focused on the platform in the beginning, and I really wanted to focus mainly on Modeler, jump into Modeler and talk about that. So I hope you understand a little bit more about what Modeler is as a piece, IBM SPSS Modeler is as a piece of the SPSS platform. Modeler, one thing I forgot to point out, it can be deployed in a lot of different ways. It can be deployed from a flexibility standpoint. It can be as flexible as being deployed solely on a workstation, a computer, and can be deployed depending on your needs as robust as having multiple servers and running models against multiple servers. So it's very scalable and allows for growth depending on where you want to start. So let's take a look at our first demonstration. In this first demonstration, it's our first use case. We're going to try to predict student success. And with this use case, I want to try to identify students that are at highest risk of failing during a given semester. So why would you want to do this? Well, we want to identify these students so we can get ahead of the curve. So if we know what students are likely to have problems, we can suggest an appropriate intervention before it becomes a problem. This is going to lead to reduced dropout rates and also lead to increased student satisfaction. So our students are going to be happier because we're identifying problems before they occur, therefore giving an intervention, some kind of study, maybe tutoring, some type of study assistance, and being able to assist these students before it becomes a problem and they're on academic probation or they fail out of our university. On the monetary side, this will allow us to increase our revenues. By keeping more students, that's going to allow us to retain more of the tuition that are being paid for these students to attend our university. So I think that goes without saying. On the flip side, we're going to reduce the costs associated with replacing students too. So as we lose students to failing out of our school or of our university, we need to replace them. And we probably have, as a university, different channels that we use to recruit students. There's a cost associated with that. So the less students that we lose because of academic probation, the more we can save of that cost associated with trying to recruit new students. And then one of the other things that comes along with having a more steady student base is the improvement of our asset management. So if we know that we have a more constant student base, I think I said user base. If we know our student base is more consistent quarter through quarter, year over year, we can use that to our advantage from an asset management standpoint. So we know how many classrooms we're going to need. We're not going to have the peaks and valleys, and we know how many professors or teachers we're going to need to meet the demand of this consistent student base. So these are all things that can be measured when creating a predictive analytics solution that can be used in your return on investment. Some are more tangible and some are less tangible, but they all add up to our return on investment when it comes to predictive analytic project. So what I'm going to do here, what I'm going to do now is I'm going to bring us into IBM SPSS Modeler. And this is the workbench that you saw in our initial slide. At the bottom, I'm just going to do kind of a quick walkthrough here so you can get a sense of what the layout of the land with this product. At the bottom, we have our palettes, and each palette has a tab. I have a source palette, record ops palette, field ops palette. I have a sources palette, record ops, field ops, graphs, modeling. These are all different palettes. Each one of these palettes contains nodes that do different things in regards to the tab, the palette tab. So for instance, the sources tab, I can connect to different types of data sources using nodes from this palette. So for instance, I have a Excel node that's going to allow me to connect to Excel spreadsheet. I have an IBM Cognos BI node that will allow me to connect to your Cognos installation. There's a lot of different types of nodes here for data sources. The field operations tab or palette will allow me to do basically make changes to or massage the makeup of my data to, a lot of times I'll use this in data cleansing, or I might want to create new fields to kind of get more meaning out of my data. These set of palettes, I don't have enough time to go through every one of them, but at least wanted to show you that you have a lot of options out here. From a modeling standpoint, you have something like, I think it's around like 27 different model types that you have to take advantage of. And we'll get to that here in a second when we go through our demonstration. The first thing I want to do, though, is I want to show you how to build this student retention model, or this sorry, not student retention, this model that we're going to use to assess student success. So I pulled an Excel node into, this is called the canvas inside of Modeler, and this is where we actually build what we call a stream. And I'm going to go into and show you the properties of our Excel file here, our Excel node. I think it's straightforward. I'm a little biased though. I've used it a fair amount. So this is where I need to point my node to where my Excel file is. And I actually have the path copied here in another window. I'm going to pull it in. Then I need to tell Modeler, specifically this node, what type of version of Excel I have, which in this case I'm using 2010. My first row contains column names. That may or may not be the case with you, and you can account for that by checking or unchecking this box. I can also preview my data by clicking this preview button. And what that will do is that'll return a subset of rows from my data source. So in this case, we're looking at the first 10 rows of an Excel spreadsheet. You may want to preview rows from say like your connection to your data warehouse or to a SQL server. So this is the data that we're going to be using today in our modeling session. And I'll give you a little bit of information about the attributes that we're looking at. So we have, some of these are pretty straightforward. Student age, their gender, do they commute or not? Have they ever had a late tuition payment? Are they an athlete? Are they a member of a volunteer of a university volunteer group? And academic probation. Have they been on academic probation before? SAT, ACT placement. This is a ordinal variable that will tell us where the student fell with respect to their entrance exams, if they were average, below average, or above average. And then, are they a member of a club or not? Okay, so we have our connection to our data source, which in this case, our data source resides on our workstation, on my workstation. The next thing I want to do is I want to instantiate this data or read this data in, and I'm going to make some changes to how the data is handled. I'm basically going to dictate what data I want to predict. I'm going to set my target variable here in this type node, and then I'm going to allow SPSS to read in the type of measurements that are that the data is. SPSS will read the data and see if it's a continuous. For instance, you see it says continuous for a numeric field, or if it's like a nominal field for a categorical variable, so on and so forth. It's very simple. I basically just connected my type node to my data source, and I'm going to click read values. What SPSS does is it reads all of the fields and finds all of the possible values that exist in the data set. So you can see here that we have some flag fields, commuter, and the values are yes or no. In our student age, it looks like our student ages vary from about 17 years old to 45. Here at the bottom, yes, no, another flag field for our member club. And then our academic probation field. Now this field is the one that we would like to predict. So in this type node, I want to set my role to target. And what that's going to do is that's going to allow me to kind of mark that field as the target field for any node downstream. So once I get to the modeling point, my modeling algorithm will take that target and try to make a prediction based on that, or try to predict that target based on the other input variables. This role field is very useful. It allows you to say whether a field is used in modeling or not. For instance, I may have in a lot of cases in your data sets, you may have like a record ID. So it could be like a primary key of some sort or some kind of, I don't know, ID or key field that's used to differentiate the different your different lines of data. So probably not too useful from a predictive standpoint, but very useful because it does individually identify each row. Well, with this role field, you can actually specify that it is a record ID by clicking this item right here, and that'll allow you to preserve that data throughout your stream. However, it won't be included into your modeling, so you won't use the ID field as a piece of the model, what goes into producing your predictive model. So there's a lot of options here. I can't really get into every piece of it, but it's a very useful field, very useful setting here that'll allow you to do a lot of things in your predictive models. So I'm going to now pull on, actually, let's take a look at the data next. So I want to grab what's called a distribution here. There's different ways to add my nodes into my stream. I can simply drag the node and drop it in. That's just going to drop it on my palette. I can also click a node in my stream and then double click the node that I would like for my palette. And that's going to add it and connect it to the stream at the same time. It's just kind of a quick way to build streams, quicker way to build streams. So what this node is, it's a graph node. You can think of it as like a graph node. And what I want to do is I'm going to choose a field that I want to take a look at. Let's take a look at volunteer. And this field has some different settings here, but let's just run it with the default values. What this is going to allow me to do is draw up a quick report, or a quick graph, and show me that it looks like the proportion of about almost 78% of our records are not volunteer group members. However, 22% are. So we can also look at this data in a different way too. We can add some other contrasting variables to contrast that a little more. Let's look at volunteer based on gender. And that's going to change our chart a little bit. So I can see that we still have the 78 to 22% split of the proportion, but now I can visually see the number of male and females that are not members of volunteer organizations against kind of the same proportion here with the ones that are members of volunteer organizations. Now, it's kind of hard to tell the difference here by eyeballing it. So I could come in here and normalize my scale so I can get a better sense of how the distribution is laid out, and I can see differences between the two. Just some different reporting things, or some different kind of data discovery things that you can do with Modeler. You have a whole slew of different graphs and charting capabilities down here under the graphs palette. I'm not going to get into every one of them, but you have a lot of different capabilities here. So the next thing I want to do is I'd like to begin exploring my data with my modeling node. And I'm going to choose a C5 modeling node, which is a decision tree. And let's take a look at the settings for this node. I have the option here under the Fields tab. I can say Use Type Node Settings or Use Custom Settings. So what this is telling me is that I have the ability to use the settings that I've set in my type node. There may be instances where I want to bypass what I've set in my type node, and I have the ability to do that. I can click on my custom settings, I can choose a different target variable if I like, and I can also mix and match my input variables in any way that I like. In this case, I'm going to stick with the type node settings. And over here on this next properties area, I can bypass if I had a data partition nodes. If I was using a partition data, I can bypass the partition or use the partition, depending on this setting here. I also have the ability to build a decision tree, which is kind of like a tree-like decision structure that you can use to visualize the data as an output. Or I can use what's called a rule set, which that is almost like producing a set of business rules. So I might have things in a rule set, a rule set output that would say something like students that commuted and were not members of a club and not athletes were always on academic probation, or something like that. It basically finds rules that are prevalent in your data, is what it does. I'm going to keep it a decision tree, and I'm going to choose all of the other defaults, and I'm going to run it. What SPSS does is it produces this gold nugget here. And inside of this gold nugget contains my model. I have my model in here. I can see there's some interesting things that come up. The predictor importance. So these are a list of the input variables that some of the input. Actually, in this case, we have a fairly small amount of input variables, so we have a simple model. So we're able to look at all of the input variables, and we can see which ones are more important and which ones are less important. Apparently, gender is less important from a predictor standpoint. We can also browse our tree. So we have our academic probation here at the top. That's our target variable. And we can see that commuter is the first split. Following that down, we can see that something like, it looks like 82% of commuters were on academic probation in this case. Now, granted, this is test data, so I hope that's not the case at any of your universities. But in this case, I can quickly go into my data set and I can find out different insights about my data in a very quick manner. So I'm going to close this out. Now that I have my model created here, I'd like to try to evaluate this model. And to do that, I have some options. I can use an analysis node, which is a node that will give us some statistics and give us basically tell us the effectiveness of how well we're predicting versus what really happened. So let's take a look here. Let's go ahead and add it. I pulled this analysis node and I connected it directly to my nugget. And I'm just going to run it with the defaults. And you can see here that the number correct was about 5,897, which accounted for about 74% accuracy. From a predictive model standpoint, it's not great. It's not bad either. Considering that 50-50, a coin flip, is 50%, we're doing better than a coin flip, much better, as a matter of fact. Now, there's ways to improve this accuracy, and that can be adding new data to my model. So, maybe there's data sets that I have, or sets of data that I wasn't aware of that that I would like to add into my predictive model. Modeler will very easily allow you to connect to that data source, depending on what your connectivity is, ODBC, or if you have a data set that you want to pull into your onto your PC, or maybe it's an actual I don't know, who knows, maybe another data set that's in, like, for instance, like Cognos or something. You can quickly do that and merge that data into your existing stream very quickly with Modeler. That may or may not be the case on adding more data may not be the prescription for increasing our predictive percentage here, which is about 74%. But in a lot of cases, sometimes you need different variables. Sometimes you need to do transformations on your data as well. And Modeler can also leverage that too. You can also leverage that using Modeler as well. So I'm going to pop back out to our slides here. And our model, we were able to successfully predict about 74% of the cases in this case. It was a simple use case. It looks like we had somewhere around 8,000 records, and we were able to successfully predict about 73%. Now, what I wanted to show you here was could be a quick deployment in this case. How could you make this tangible? Obviously, you have that nugget. Everybody would need to have access to that nugget in some way. Well, one thing I did for this slide was I connected another output node to that that nugget so I could actually see the records. I could actually see the records that were input. I could see what the model predicted, and then I could see the confidence that the model had on its prediction. So let me show you this here. Column J, which is what I'm trying to circle right here, this is the model prediction. So our model, and let's take this first record as an example. The model predicted that yes, this person who is a 24-year-old female would be on academic probation and had a confidence of 0.9. So the higher the number, as that number approaches 1, 1 being the highest, 0 being the lowest, as I approach 1, the algorithm has a higher confidence that the prediction is accurate. And we can validate that over here in column G. We can see that what happened was indeed this female was on academic probation. And you can see here that something like the first, I'm not going to count them all out here, it looks like the first 7 had a similar confidence of about 0.9. And then down here at the bottom, our last 2, we had a little bit lower confidence, 0.88, 0.88. And we can see here that we were right on one and wrong on the other. Now, who knows how many 0.881 confidence records there were, but I put this up here so you could see that this is how we evaluate the effectiveness of our model. If our predicted matches what really happened, then that's a success. A failure is listed right here, and it's something that as a person that's working in Modeler, you need to be able to go in and quickly pull in and evaluate, either using an analysis node to look at the aggregate effectiveness, accuracy I should say, or coming in and looking at a detailed level and being able to understand quickly what's going on. Well, this report, which is what you're looking at here, an Excel report, could be handed to an advisor, for instance, and or a list of the students that had a high probability of being on academic probation could be disseminated to whoever the advisors were for that individual, and then the appropriate steps could be taken to assist that person so before probation or failing out would be an issue. So I hope that use case helped you think a little bit about using predictive analytics to predict something that could be very useful for an organization. The next thing I want to do is I want to look at something that's more focused on the financial side of a university. And what I want to do is I want to try to, the bottom line of what I want to do is I want to try to figure out the amount of donations that I'm going to get from alumni for a specific year. Now to get there, what I'm going to do is I'd like to try to group my alumni donors I'd like to place them into groupings. And then I want to try to produce a projection, or a prediction, I should say, on what that group of donors is likely to give for that year. Adding up the sum total for all those groups will then give me a total, or a forecast almost, of what's likely to be donated for a year. So why would you want to do this again? Well, I think it goes without saying that having a better idea or a better forecast can definitely help us plan for the future for sure. The grouping part, it can do some interesting things. Grouping these alumni or these donors into kind of, grouping into subgroups can help you gain better understanding of their makeup. So we can understand demographics and socioeconomic factors of why they may give more or may give less. That'll help us prescribe the most effective marketing message to these people. In addition to that, we can use those forecasted revenues to improve our planning for future projects. So if we have a solid idea of what is likely to be donated, we can then have number one, more confidence in our planning for, let's say, capital improvements or maybe expansions of some sort for our university, things that we have kind of in motion. So let's take a look at this model. In this case, I've already started a stream, and I'll show you what the data looks like. I'm going to skip over the properties for these nodes, but I just wanted to show you the preview of what this data looks like. So I have here some similar fields. So I have the gender field, if the individual is married, has children, has a spouse in the database. If they've ever attended one of our marketing events, their age, number of years since graduation, and then the amount that was donated. This is going to be our target variable. The sum field will be our target variable. I'm going to hit OK here. So I'm going to go into the type node and make sure I have my target specified, which I do. I've got amount sum specified as my target variable. And then I want to show you this other node here. In the first example, I used a distribution node to kind of get a better understanding of the layout of my data. I just chose a field and we looked at kind of a distribution of what the data looked like. Well, this data audit node, which is this node right here, it's located under the output palette. It's right here. This is a very useful node because it'll give you some statistics on your data, give you a lot of statistics on your data. You can see here that I have all of my variables on here, and I can see different graphs for each one. Let's look at this age here, this age field, this age graph, and I can see that it shows me on the x-axis, I can see the amount given. As we move to the right, the amount increases, and I can see the age of the donor as the age increase. As we move vertically or up, the age increases. So I can see that there's a higher concentration up here at the top, and I can see these, they're almost like outliers here at the top. So these are basically older, for instance, this bullet point that this marker that I'm mousing over here, this individual is 77 years old and gave about $35,000. As I move over here, I can see that I still have around an 88-year-old individual that gave a little bit, well, quite a bit less, about 1,600. And then here at the bottom, we can see we have a 37-year-old that gave around 680. So you can see kind of the distribution of the data for your various input variables. Let's go ahead and get started. The first thing I'd like to do is I want to pull in, I want to build these groupings for my alumni donors. And what I'm going to use is, it's called a k-means modeling node. K-means model. I'll show you what this looks like here. This is very similar to the C5 properties. So I can use the type node settings or not use them, depending on what I want to do. In this case, I would like to use them. I'm going to accept all the other defaults. I can also specify in here the number of clusters. So if I have a need to produce a smaller or greater number of clusters or groups, I can do that. I'm just going to hit run. And we're going to use all the defaults. What that did was produced a nugget right here. And we can go in and take a look at the result set. It looks a lot different than our decision tree result set. What you're looking at on the right is a representation of all of the clusters. And we can see that there's different groupings. We have, for instance, cluster 2 here makes up about 41.5% of our donors. And our smallest cluster is about 10.5%. We have an evaluation chart here on the left called cluster quality that shows us the density of these groupings, or you can think of it as almost like overlap. How much overlap is there between the clusters? And we can see here that our rating, the way you read this is this purple bar in the middle, shows us that we have an average silhouette of about 0.3. So we're in this fair area. So we're not good, we're not great, we're not bad either. We're in this kind of acceptable fair area for this case. For a demonstration, I think that's acceptable. So that's all good and great. We have these clusters, but I want to find out, as an analyst, I want to come in and I want to find out some of the makeup of these clusters to understand what defines these groups. So what I can do is I can go into my view and I can click on clusters down here. Let me just maximize this so you can see this a little better. And I have my clusters here. So look here. So this cluster 2, this corresponds to our red cluster, our largest cluster, 41.5%. And I can go down and I can look at how each one of those variables fared for, at least in the majority for this cluster. I can see that 83.6% of the donors attended an event in this cluster, and 89.5% had children. And there's a lot of interesting things. Most of them are female, it looks like. About 76.5 of these donors were female, and the average age is about 57. I can also look at Let's look at cluster 3 here, which happens to be the smallest. This group is predominantly single, mostly did not attend events, none of them have children, and none of them have spouses in database. That's interesting. We can also see that the majority are male and the average age as well. So these appear to be single people, maybe living at home still, not unmarried, and not attending events. So those are some interesting things that we can find out, or interesting things that we can know about these clusters of these groupings. And we can name these clusters to give them more meaningful names. So when we talk about them as analysts, we can have an easier conversation rather than saying cluster 1, cluster 2, cluster 3. So what I'd like to do next is I'd like to give these clusters more meaningful names. And I'm going to use this node called a reclassify node. And reclassify, I'm going to use it in a pretty basic way here. But this is a very powerful node that allows you to do a lot of different things to your data. In this case, we're going to point the reclassify to the k-means field. And let me show you something here before I get too far into this. So I'm going to pull up an output here. I want to add a table so you can see what actually happened after we have this nugget now that we created. I want to show you the net effect of what that nugget does. I'm just going to pull this table on real quick so you can kind of visually see what happened. So we have all of our input variables: gender, marital status, children, so on and so forth, all the way here to our actual target variable. Over here on the right, the furthest right column is this $km means field. And what that is the cluster where this record fell. So we can see that this male that's married, that has no children, that doesn't have a spouse in the database, that did attend an event, that's 49 years old and has been 27 years since graduation and donated $80, falls in cluster 1. So that's the net effect of what kind of the tangible thing that actually happens to the data after, in this case, we've added this model, this k-means model. We've added a new field to our database that intelligently tells us what cluster or what group the record fell into. I'm going to remove that table. And I tell you that because what I'm going to do here is I'm going to point my reclassify field onto that newly created field, the k-means field. I'm going to rename this. I'm going to call it cluster name. And what I'm doing is I'm taking this field, and it's very basic. I'm basically taking this cluster field that was created from our modeling node, and I'm going to give each cluster a new name. So instead of cluster 1, I'm going to call it something else, and instead of cluster 2, that's going to be named something else. So I click Get Values, and what that does is it gets all of the independent values that are listed in that field. I already have the cluster names defined, so we can add them. I'm just going to add them here. Bear with me while I copy and paste. Okay, so now we have new cluster names for our values. So we know that the Peakton High School Rob Lowe group, cluster 3, is probably the group with the single folks that probably live at home still, and they gave less. And we know that the Mike Brady group was the male with a family that had kids and a spouse potentially a spouse in the database. I think it was maybe 50% or something like that. Most had a lot of spouses in the database. So that way we can have a more meaningful name of the cluster. So let's take a look at this data and see how it actually fares with respect to the cluster. I need to find my graph. There it is. I'm going to pull this new graph node out here. It's called the graph board. And it's a pretty flexible graphing node. What I'm going to do is I'm going to select the field that I like, which is this cluster name. I'm going to choose the amount given so I can see the actual amount given in my data set by cluster or by grouping. Let's choose a bar chart to display it. Click Run, and I can see that Mike Brady, the Mike Brady cluster, gave the most, $330,000, and the Peakton High School Rob Lowe group gave about $11,000 during the same time period. So what we've discovered by looking at this chart of actuals, the actuals by cluster, we've discovered the natural groupings for our donors, and we've established which groups give more and which groups give less. So that's very useful. The next thing I want to try to do is I want to try to make a prediction or projection on the amount that they're likely to donate. So let's take a look. Let's move forward with that. I'm going to pull in a new node here called feature selection. And what feature selection is for is it will tell us, this node is a modeling node that tells us gives us an idea on which variables are the most significant to our the most significant. That's the way you can think about it. The properties are similar to our other nodes. I can use a type node or not use type node. I'm going to use all the defaults in this case. I'm going to run it, and then we'll be able to see our output here. So with feature selection, what it does is it runs an evaluation, gives us a value here that kind of gives us a scale on how important or unimportant a variable is. In this case, we have ranked our fields. So age, attended event, year since graduation. These are all important variables. And we can see as they approach 1, they're more important. Well, these other fields here, for instance, marital status, gender, children, so on and so forth, these are less important. And we can include these if we wanted to. They don't have to be excluded. However, by default, they get unchecked. To include these variables into our model, we can simply check the ones that we want. So in this case, I would include all the variables into my final modeling, my modeling node. In this case, I'm not going to. I'm just going to leave them out and just keep the important ones. We could go either way, but in this case, I'm just going to go with the important variables. So let's go ahead and pull in our modeling node. And what I'm going to use here is a cart node. Here it is, which is another decision tree. And I'll show you what the settings are here. They're a little bit different. Actually, they're different than this, little different than the C5, although I do have a target specified and I have my inputs available too. I can also customize the setting too. So if I have the need to change my target or mix and match my predictors or inputs, I can do that. And you have some different expert options here too. So as you gain more experience with each one of these modeling nodes, you may want to kind of tweak the way that the model runs. In this case, I'm going to take the defaults, and I'm going to produce our modeling nugget. And actually, I didn't want to jump in there. What I wanted to do was I wanted to pull out a graph board so we could look at the predicted amount. So let's go ahead and grab our graph. And I'm going to, in essence, do the same. I'm going to create the same chart as we looked at before with the graph board. I'm going to choose cluster names, but in this time, instead of choosing the amount sum field, which was our target variable, we're going to choose this $R amount, which is our predicted amount given. So we can see how this model predicted that the cluster would give. In this case, I think Mike Brady, we predicted about 290,000, and they gave more than that. They actually gave 330,000. The Peakton High School Rob Lowe group gave more than what the actuals were, 16,000 versus 11,000. So we can see that, yeah, we're not right on. However, that may be close enough for you to, that could be close enough from a forecast standpoint, to be able to make decisions, to be able to have an idea of what is likely to occur, what's likely to occur, what's likely to be donated for a given year. So let's move back into our slides. So some of the takeaways from this modeling session: we discovered five distinct groupings of donors, and we identified the characteristics of each one of them. I didn't go through every cluster, But each one of those groups or clusters had different defining characteristics. For instance, the Mike Brady cluster, cluster one, donated the most, but only contained there were so 15.4% of our donors uh, the most made up the largest amount of the donations. So $330,000 was associated with 15.4% of our donors. 91% were married. They were all male, and they averaged about 58 years old. And I've showed I've listed here the predicted amounts and also the cluster sizes here for your reference if you'd like a copy of this slide so you can use that in your evaluation. Okay. So we've went over a lot today with respect to Modeler. We've talked about predictive analytics, and we've talked about predictive analytics, how SPSS as a platform and SPSS Modeler as a data mining application can assist you in creating insights out of your data and also producing predictive models. I gave you some use cases on public sector use cases, so some crime ideas, ideas on use cases, and also university and some other things that kind of transcend, you know, kind of transcend industry. So workforce management type things, employee, understanding about employees. We also jumped into two demonstrations of two use cases that I think are very tangible from the university portion of the public sector. Now, I want to give you some things to take away from this presentation. So you saw how quickly I could create these models. Yes, it's a demonstration. So I'm using a it's a pretty simple data set, just a minimal amount of variables, but I'm able to quickly gain insights on those data sets using SPSS Modeler. So in a very short time frame, I could be productive with this and produce results that are actionable. In the first example, we produced a report that could be shared with people of interest that are advisors for students that are having issues, that can assign an intervention to these students that are predicted to have problems before the problem happens. We talked about the benefits of that. Not one time did I have to create code to produce my model. I used nodes that were included inside of SPSS Modeler. Yes, you can configure the nodes to meet your needs. I didn't have to produce any code or I have any knowledge about programming language to use Modeler. Now, you have the ability to inject code into Modeler and also utilize R, which is another statistical product and data mining product. You can actually use R code and integrate that in with your SPSS if you like, SPSS models. So you have that ability if you desire. If you don't, it's not required. SPSS, the licensing is very flexible and the deployments are very flexible. So I can license an SPSS Modeler instance on one desktop at my organization to kind of get started. I can produce models, I can gain insights on my data, and I can even, of course, you can increase that as much as you like. I can have multiple analytical servers. I can have collaboration and deployment services set up to integrate in with my online systems and offer predictions at the point of impact with my customers or with my employees if needed. Taking that a step further, the integration piece really allows you to leverage the investments you've made in technology. So I don't need to put a lot of money into integrating custom code to bring my predictions or bring my predictive models into use by my systems. I can leverage technology that's available inside of the SPSS platform to do that for me. Some other things to point out. SPSS Modeler doesn't require you to report on or report from a specific proprietary format of data or database. You can, I think I've heard the term SPSS Modeler is data agnostic. I've heard the term that Modeler is platform agnostic. Data can be structured or unstructured, meaning that you can report on structured data like in a data warehouse or maybe like a SQL server. all the way down to something as simple as a CSV spreadsheet or Excel spreadsheet. And you can also leverage unstructured data, so for instance like server logs or social media data, things like that. So I hope I've given you a lot of some ideas on how to apply this technology at your organization, and I hope I've given you just enough information on the SPSS Modeler product to spark your interest. That's the biggest thing. I myself am a very curious person, and having a tool like this at my disposal has been very very helpful from when I've worked in analytical functions. I can allow you to very quickly gain some insights on leveraging large sets of data, and can be a very powerful tool for you as at your organization. So now that we've gotten through really the bulk of the content, I'm at the point now where I can start taking some of these questions that have been popping up. I don't have a whole lot of time here, so I'm going to try to take one or two of these questions that have been popping up in the chat window. So the first question is, how did you know what modeling node to use when building the stream? So that's a great question, and so it's this is a demonstration, so I knew ahead of time what I was going to use. But if I was an analyst going into, if I was an analyst that understood the data, but maybe didn't have a good grasp on the type of modeling algorithm to use, I can leverage capabilities inside of SPSS Modeler that will choose the modeling algorithm for me. So I want to show you one thing here inside of Modeler. This is something that I didn't show you in the demonstration. Under the Modeling tab, I have all my models here, 27-ish models. I have these three auto models here: auto classifier, auto numeric, and auto cluster. Now, depending on the type of modeling that you're doing, in this case I was using a cluster model, so the k-means is a cluster model. I could have used this auto cluster here, and that would have told me the best type of cluster model to use, because I have a whole slew of them, a whole slew of cluster models here that I'm able to leverage. Consequently, I'm using a classification model here under the cart portion of the stream. I could have used the auto classifier to tell me I could have used an auto classifier in this case. Actually, maybe the better example is the C5 here. I could have used an auto classifier in this case to tell me what type of model to use. And what that does, that classifier node, it will actually take, and you can tell it which models you want to try to evaluate. It'll run those models in sequence, and based on your kind of your evaluation criteria. So if you're looking at like R squared or something, if you're using R squared or some other kind of some other statistic to evaluate your model, you can run those models kind of in sequence, get the results, and then compare them side by side. And SPSS will also give you a recommendation on which model is the best or gives you the best result. So that's very useful if you're worried about model decisions, the type of algorithm decisions to be made. You can leverage that capability inside a modeler, and it'll tell you which type of model to use. And this next question I'm going to take, this will be the last question. I know we're running out of time here. This is a question I always get. Will Modeler connect to SQL Server? And the answer is yes. It'll connect to SQL Server. It'll connect to anything. It's like I said, the platform, the tool is platform agnostic. So anything from a SQL Server, an Oracle server, your enterprise data warehouse. I've used Cognos also as a data source, which is basically just a front end to some database. But if you as users have IBM Cognos at your organizations, you can leverage your reports and your metadata as inputs into an SPSS modeler stream. So that can be very useful and actually get you up and running extremely quickly. So I appreciate your time. I hope you'll come away with this with some new ideas on how to leverage predictive analytics at your organization. And please don't hesitate to contact me or our company if you have further questions about Modeler or would like to see a demonstration using specifics at your company. We would love to assist you. Thank you very much for your time.